Can you imagine paper acting as a battery? Do you know stab-proof and bulletproof jackets are made with carbon? Have you ever thought about a transistor being made with carbon? Have you heard of the growing field, molecular electronics? Scientists say the next big thing after the internet is CNT, carbon nanotube. It is a carbon material with a cylindrical nanostructure belonging to the fullerene form of carbon. A fullerene is any molecule containing only carbon atoms in hollow, spherical, tubular, and ellipsoidal forms. There is a very important and complex science of carbon. It is called organic chemistry. There is a challenging technology based around carbon. It is called nanotechnology. Let's study the significant role played by carbon in organic chemistry. There are four main sources of organic compounds. They are petroleum, coal, natural gas, and plants and animals. We get organic compounds such as petrol, kerosene, and lubricating oil from petroleum. Coal tar is another source of organic compounds such as benzene, toluene, xylene, naphthalene, etc. Natural gas primarily consists of methane, ethane, propane, and butane, with other fossil fuels. Natural gas is created by methanogenic organisms in marshes, bogs, and landfills. Natural gas is commercially produced from oil fields and natural gas fields. Plants such as sugarcane and beets give abundant sugar. Other substances of major importance that are derived from plants include starch, cellulose, caffeine, and amino acids. Animals feed on plants and other animals to synthesize amino acids, proteins, fats, and carbohydrates. What would happen to organic chemical industries if petroleum was not available? During World War II, Germany was forced to find out when it was cut off from petroleum and natural gas sources. The chemists proved that they could synthesize many organic compounds based on ethine, which in turn can be synthesized from limestone and coal. Until 1828, it was believed that organic compounds could not be synthesized in the laboratory. In fact, the chemicals were classified into two major categories, namely organic chemicals, the substances produced by living organisms, and inorganic chemicals, the substances not produced by living organisms. But this was disproved when Friedrich Wöhler, a German chemist, synthesized urea in the laboratory. He was able to synthesize this first man-made urea from the inorganic substance ammonium cyanate. Urea is an organic substance found in the urine of many animals. Wöhler's experiment broke down the barrier between inorganic and organic substances. Modern chemists consider organic compounds to be those containing carbon and one or more other elements, most often hydrogen, oxygen, nitrogen, sulfur, or the halogens, but sometimes others as well. Organic chemistry has had a profound effect on life in the 21st century. Natural materials have been improved, and natural and artificial materials have been synthesized, improving health, increasing comfort, and making valuable additions to many products manufactured today. There are organic chemicals that make up your hair, your skin, your fingernails, and so on. A wide variety of substances such as drugs, vitamins, plastics, natural and synthetic fibers, carbohydrates, proteins, and fats consist of organic molecules. Organic chemistry is a branch of chemistry in which carbon compounds and their reactions are studied. The diversity of organic chemicals is due to the versatility of the carbon atom. Why is carbon such a special element? Let's look at its chemistry a little more in detail. Carbon appears in the second row of the periodic table and has 4 bonding electrons in its valence shell. Since the carbon atom has 6 protons and 6 electrons, it is neutral. 2 electrons are revolving in the K shell and 4 in the L shell. It needs another 4 electrons to satisfy its valence shell by the octet rule. Carbon therefore forms 4 bonds with other atoms. Each bond consists of 1 carbon electron and 1 hydrogen electron. Every valence electron participates in bonding. Thus, the bonds of a carbon atom will be distributed evenly over the atom's surface. These bonds form a tetrahedron, a pyramidal structure. Look at the structure of methane, a simple hydrocarbon. Methane contains a single carbon atom bonded to 4 hydrogen atoms. Carbon has the ability to form covalent bonds with other carbon atoms in long chains. This property of chain formation is called catenation. Catenation is the property of direct bonding between atoms of the same element. The terminal carbon atoms of a long chain can meet each other to form a ring structure. This chain and ring formation distinguishes carbon from all other elements. Other elements hardly ever form chains of more than 8 atoms. For example, sulfur can form a ring of a maximum of 8 members. But look at the varieties of chains and rings based on the carbon atom. Carbon can form an open chain with and without a branch, rings with single bonds, a few double bonds, and a heterocyclic ring. Aliphatic hydrocarbons contain straight chains and branched chains. Examples: N-butane and 2-methyl-propane. The chains with carbon-carbon single bonds are called saturated hydrocarbons. Unsaturated hydrocarbons have a double bond or a triple bond. Example: N-butane and 2-butene. Cyclic hydrocarbons are further divided into alicyclic, aromatic, and heterocyclic hydrocarbons. The first known aromatic compounds were isolated from substances with a pleasant smell. Hence, they were named aromatic compounds. Example: benzene. A heterocyclic compound has a ring of carbon atoms along with an atom or more of another element. Hetero means different. Nitrogen is the heteroatom in the carbon chain of pyridine. Throughout organic chemistry, carbon shows a covalency of 4. This property of carbon accounts for the large number of known compounds running into several million.